In the 18th century, magnifying glass are used to start fire and ignite materials. What are the special characteristics of magnifying glass which allow such phenomenon? At the end of this lesson, you should be able to state the characteristics of images formed by a convex lens, draw a labeled ray diagram to show the formation of images by light rays passing through a convex lens. The magnifying glass is actually a convex lens that can focus the sun's rays on a small area and can therefore ignite materials. A convex lens is a lens that converges rays of light traveling in parallel to its principal axis. As its name suggests, the convex lens can converge light rays to meet at a point known as the focal point, represented by F. Let's investigate the characteristics of the image formed by a convex lens by using ray diagrams. The diagram shows a convex lens. The center, O, of the lens is called the optical center. The line which passes through the focal points F and the optical center is called the principal axis. The point on the principal axis where light rays will converge after passing through the lens. The distance between the focal point and the optical center is called the focal length, represented by F. The image formed by a converging lens can be made by using two principal rays. Ray 1 is the ray which travels parallel to the axis, and after going through the lens, it passes through the focal point. Ray 2 passes through the center of the lens. The point of intersection of the two rays is the position where the image is formed. The distance between the object and the optical center is called the object distance. The distance between the image and the optical center is called the image distance. What are the characteristics of the image formed? Characteristics of the image formed are real, inverted, and diminished. The image is formed at the opposite side of the object. Real, meaning that the image can be captured on the screen. Inverted, meaning that the image is upside down. Diminished, meaning that the image is smaller than the object size. What happens if we put the object at a different object distance? Now let us see what happens when an object is placed between F and 2F. Click at the lens to find out. Can you describe the characteristics of the image formed? Is it the same as in the previous case where the object is placed beyond 2F? No, it is not the same. When the object is placed between F and 2F, the image is real, inverted, and enlarged, meaning larger than the object size. We can conclude that the characteristics of the image formed by a convex lens depend on the object distance. You have learned how the image is formed by the convex lens. Now let us study the characteristics of the image formed by convex lens. The apparatus is set up as shown above. The object distance is fixed. Then the lens is adjusted until a sharp image of the object is formed on the screen. What do you observe? What conclusion can you make from the experiment? An image is formed on the screen. The image formed is smaller than the size of the object and it is inverted. When the object distance is more than 2f, the image formed by the convex lens is real, diminished, and inverted. Let's look again at the image formed by the convex lens. Can you state its characteristics? In this lesson, we learned that the formation of image by convex lens can be shown by drawing ray diagrams. The characteristics of the image formed by a convex lens depend on the object distance. The image is also formed on the opposite side of the object. How can a convex lens be used as a magnifying glass? Where would you put the object? Click on the lens to know. The object must be placed in between F, focal point, and the optical center. The image formed is A. Virtual, B. Upright, C. Enlarged.